Hello everyone, welcome to Ganit. Today we are going to talk about, like I had discussed in my previous videos as well, we are going to talk about questions based on midpoint theorem, converse of midpoint theorem, and intercept theorem. So I have a question here that says ABCD is a quadrilateral in which AD is equals to BC. That's a very important information. So AD and BC are equal to each other. Also, it goes on to say that PQ, R, and S are the midpoints of the respective sides. So let's just try and observe what are the triangles where there is a possibility of applying the midpoint theorem. As discussed earlier in my concept explanation videos, where I had told you that if we notice two midpoints, then we will go about the midpoint theorem. But if we notice only one midpoint and a parallel line, we will go with the converse of midpoint theorem. Since there is a lot of midpoints given in this question, we have four different midpoints given in this question. So good chances are that this question is a midpoint theorem question, not a converse question. Okay. So, by the way, Merry Christmas, everyone. I hope you all had fun. You all had a good festive season, but we are getting into the exam, so yeah, I am here to spoil that mood a little bit. Okay, so let's begin with this question. So if you notice triangle BAD, I can very clearly see that P and Q are midpoints. So I have a triangle where two midpoints are given. I'm going to start with the midpoint theorem. So that means I can say that PQ is parallel to AD and PQ is half of AD. Now, you can also see in triangle CAD, if you see there, you will observe that R and S are the midpoints of the sides CD and CA. So I will write it here. R and S are the midpoints. So I can say that RS is equals to half of AD, but RS is also parallel to AD. So I have two things which are equal to half of AD, correct? So it's very easy to spot that these two will be equal. We can easily say from equation 1 and 2 itself that since both of them are equals to half of AD, I can easily say that PQ is equals to RS. All right, I will write it here from 1 and 2. Let's move further. So I have triangle ABC where you can see P and S are the midpoints of AC and AB. So P and S are the midpoints. So I can say that PS is half of BC and PS is parallel to BC. Guys, please remember everything that is happening here is by midpoint theorem. Everything. All the equation 1, equation 2, all these results that I'm writing is based on midpoint theorem because two midpoints in a triangle is a clear green flag for us to go ahead and use the midpoint theorem. All right. Okay. Now, so we have got PS is parallel to BC, this side, and we have got PS is half of BC. All right. Now, let's see triangle DBC. What I can say there, what I can see there is DC has a midpoint R and DB has a midpoint Q. So I can say Q and R are the midpoints. So I can say QR is half of BC and QR is parallel to BC, right? So if you notice, this is equation number 3 and this is equation number 4. And there again, sorry, this is equation number 3. So if you notice, they're both equals to half of BC. So very easily we can say, therefore, PS is equals to QR. So we have a figure where opposite sides are parallel and equal. If you notice the quadrilateral PQRS, what did we just prove in quadrilateral PQRS? We proven that PS is equals to QR, and we have just proven that PQ is equals to RS. Here, PQ is equals to RS. So I have a four-sided figure where opposite set of sides I have proven parallel and equal. That means bare minimum I have a parallelogram. Correct? That's the basic, most important and basic property of a parallelogram, where opposite sides are parallel and equal to each other. That's at least a parallelogram. You might think that it could be a rectangle also. A lot of times my question, I get these questions asked to me that why not it is a rectangle. See, please understand, parallelogram is a basic structure, rhombus is a basic structure. But if you go on and prove that it is a parallelogram with four or at least one right angle, then it becomes a rectangle. So parallelogram is bare minimum, but if you can prove one angle to be 90-degree also, then it is a rectangle. Similarly, rhombus is bare minimum. If you can prove a rhombus with at least one 90-degree angle, then it becomes a square. So please remember, proving opposite sides as parallel and equal is a good enough criteria for the figure to be a parallelogram. So no overthinking there really, please. I request, because a lot of times I've seen that just because of overthinking, what if this is not true? What if this is correct? What if this is wrong? Just because of overthinking, you let go of the most fundamentals of the thing. Okay, so please understand, proving parallelogram is quite simple. Opposite sides parallel and equal, they're all equal. But in this question, there was a special criteria given to me in the beginning. AD equals to BC. So by all accounts, PQ and RS, which were equal because of AD, and PS and QR, which were equals to BC, if you see here, I can say that because AD is equals to BC given to me, it's given right in the question. I can say that PS is equals to QR is actually equals to PQ is equals to RS. See, I'll explain this point again. So PQ is equals to RS we had already proven. It happened because they were both equals to half of AD. I have also proven PS is equals to QR, but why did it happen? Because they were both equals to half of BC. But don't you think AD and BC, as given in the question, were already equal? AD and BC were already equal to each other. So if AD and BC are equal to each other, then the result that AD and BC are individually producing, they should be also equal to each other. So PQ is equals to RS should actually be equals to PS is equals to QR. And as a result, what we get is that PQRS is a quadrilateral where all four sides are equal. Opposite sides were parallel and equal, absolutely. But we later on go and prove that all four sides are also equal. And that proves us that PQRS is a rhombus. So I hope this question is clear to you. It's a very important question. It has been asked in multiple final exams in various schools. From midpoint theorem's perspective, this is a pretty relevant question. So I will upload this video of explanation today. You can go through the video. If you feel that there is any particular part of the question that you're not getting, you can absolutely comment on that, and I can create a separate video to explain those things. So that's really not a problem. But I hope I have tried my best to keep it simple so that you can all understand it. All right. Let's move to the next question. So again, this is a question where a parallelogram has been mentioned. If you see the previous question, it was saying in the adjoining figure ABCD is a quadrilateral. It was just a quadrilateral. We didn't know any specific details about what kind of quadrilateral it is. Now we know that we are dealing with a parallelogram. It's specifically mentioned. So first thing what we do is we construct a little bit. I join D and B and I mark this point as O. All right. Now I'm going to start the solution for this question. It says there is a parallelogram. So parallelogram, guys, please remember it brings at least opposite sides as parallel and equal. Now let's try and decode this information a little bit. CF is equals to 1 by 4 AC. Now, this is my favorite question to ask in quadrilaterals. A lot of times my students just hate me for this. I keep asking them, what is the diagonal property of a parallelogram? And that's still the better question. You should see the faces when I ask, what is the diagonal property of a rhombus? I mean, it's amazing. So, I mean, diagonal properties are so crucial, not just in ninth grade you're doing quadrilaterals, midpoint theorem, intercept theorem. In grade 10th you encounter similarity of triangles. In grade 9th you have congruence of triangles. There are so many applications of diagonal properties that this cannot be ignored, really, guys. Okay, so please understand, I'm going to use diagonal properties here. It's a parallelogram, so the diagonals are bisecting each other. We know that much. It's a basic property of a parallelogram. Diagonals bisect each other. Okay. So if I look at triangle CDO, what you will notice is that CF is equals to 1 by 4 AC. The question says that. But I also know that CO is equals to 1 by 2 of AC, because CO is one part of the diagonal. Which diagonal? AC. We also know that O is the midpoint bisecting each other, right? The diagonals bisect each other. Therefore, I can easily say that CO is equals to half of AC. What is half of half? It's 1 by 4. So I can very clearly say that because CF is 1 by 4 of AC and CO is 1 by 2 of AC, I can very easily say that CF is equals to 1 by 2 CO. CF is equals to 1 by 2 CO means what? That F is the midpoint of CO. Okay, so that means F is midpoint of CO. How did I get that? By just using these two things. Okay, very simple to understand. It's not at all a difficult question. Now, we will move to the right side of the triangle. I'm going to talk about a different triangle now. Triangle CBO. Now, you just saw that we have proven F as the midpoint of CO. So I'm going to use that. Please remember, if I have used uh, by midpoint theorem, I can very clearly say that E and F are both midpoints. So I can also say that in triangle CDO, EF is parallel to DO and EF is half of DO. Okay, just by using MBT, midpoint theorem. So now we'll come to triangle CBO. If you notice in triangle CBO, F is already a midpoint, correct? From here. And FG is parallel to BO. From where? Here. Now you might say that sir, EF was parallel to DO. How is FG parallel to BO? FG is also parallel to BO. Guys, please understand, if you are talking about a straight line, a part of that straight line is parallel to each other, that means the whole straight line is parallel to each other. It's not that you have one part as parallel to the other part, but the other part would not be parallel. It doesn't work like that in mathematics. Please understand, a straight line doesn't have bends or edges. A straight line is a straight line. So if I say one part is parallel to other part, the entire line is parallel to the other line. So FG is parallel to BO. So as per my explanation videos, one midpoint and a set of parallel lines brings us converse of midpoint theorem. So we can say that by converse of midpoint theorem, G becomes the midpoint of what? Of BC. And if you see here, we have to prove that G is the midpoint of BC. So we can write proudly, hence proved. All right. I hope you all understood this question. It's not really a difficult question. In this question, the trick lies here. Figuring out these two things, decoding these two things, and getting a relation out of this, that's the most important aspect of this question. All right. I will hope that this question shows up in your exam. The questions I am explaining, look, I have to be a bit greedy at this one, right? I mean, if I'm explaining you questions, it would be so much more fun if those questions can actually show up in your exam, right? So in the next slide, we will discuss about two more types of questions, and probably we will not close the chapter really. I will keep uploading more questions on the same topic, but yeah, for now, after two more questions, we'll start a new topic. Concepts first, and then the questions. I hope you are enjoying this. I hope you like the explanation and you like what you see. Let's catch up later. Thank you.